Hey YouTube, Jay Kilroy here, back in the shop. Gonna make some chips. Spending too much time making plastic pieces. I want to get this power feed adaptation finished up. Got my 3D printed adapter here. I did go make the change to put the slots in for the captive nuts, for the 1/4x20 bolts or nuts, the bolts and nuts that will be holding the power feed onto the adapter. So, but we got to do some things first. We've got to take the bearing retainer ring and put an extra set of holes in it for these 5/16 by 24 holes. And so I've got that part in the lathe. That part had so much, you know, somebody that owned this mill in the past painted it with house paint. I swear to God, it's either house paint or it's black Krylon, one of the two, or maybe what's that other anti-rust stuff, D-Rusto, something, I don't know, you know, some kind of black enamel that's just terrible. And anyway, there was so much paint gooped on there that I threw the bearing retainer in the lathe, and we're gonna make some cleanup cuts just to get rid of all that paint to clean the part up and give us actually something to work with, because it's nasty. So let's move the camera over there, and we'll do that next. All right, here's the part in the lathe, and I've already taken a cleanup cut on this out OD. Literally just the minimal amount that I could take off to get rid of all the paint. And I took a little very slight face across this front, put a nice chamfer on this corner here so that I don't cut myself wide open. And you see I'm holding it on the ID, and the ID is the one that's really bad. So got a ton of paint gooped up in here. So I'm going to swap these jaws around, grab it on the OD, and then we're going to go ahead and take a cut on the ID. Then we're going to move over to the mill and put this extra set of holes in here. All right, we're going to go ahead and swap our jaws around here. And you know, this is a task that you do a lot if you're doing a lot of work on the same machine. So you notice I have a glove on my left hand. That finger that I sliced, those fingers that I sliced are still recovering, and I don't want to get cutting oil and other contaminants in those areas. So I'm wearing, this is just nitrile gloves. These will tear quite easily and rip right off your hands, but I will be very careful. So my favorite tool for changing the jaws around is a little air ratchet. And this is just a little cheapo, Husky, you know, Home Depot brand 3/8" air ratchet. But it sure does make the job a lot easier. All right, we're swapped around. clamped in here. Okay, I've already taken a facing cut on this thing, and I just want to clean up this ID, so I'm just going to manually here kind of line it up. Spin it around a little bit. Alright, we got us a little boring bar in here. This is just a very simple TPG inserted boring bar here. And we're just going to clean this surface up so that it gives us a good surface to indicate off of. That ought to do. Give us a nice clean surface that's turned concentric with this outer surface, so we'll have a nice ID to indicate off of. So let's take the part and let's move over to the mill. Alrighty, we got our part in the spindle here. We've got an indicator, and this is the trusty Noga indicator holder that's designed to go in your spindle nose. It's in a drill chuck right at the moment. And so I'm indicating front to back. All right, real close there. This is a 10th indicator, so it's probably a bit much for this app. There you go. So that's front to back. So that gives me a real good, I'm real close there on my Y. So I'll zero my Y. And then I'll go on the X and do the same thing. A little bit of a ways out there. So once I've got my part centered on the X and the Y, I zero both of them, then you can just give it a swing around and you should stay pretty darn close. By the way, this isn't a 10th indicator, this is 5/10 indicator. So I'm within 5/10 here all the way around, so that's certainly good, way good enough for this application. So we're going to go ahead and break down the take the indicator out. That's a little compact. Take my Noga setup out here. Here's the little Noga indicator setup. So here's the little change to a wider field of view so you can see a little better. This is a little Noga indicator setup. I don't remember what number it is. but it sure is nice. Love everything Nogan. I've got a drawing for this part right here, because better drawings make better parts, at least for me. And what you see here in the drawing is the existing centers of the existing holes, right? And then the centers of the new holes. So what we have to do next is we have to line up, now that we've got it centered here between this V-jaw and the fixed jaw, we've got to get this rotated to where these holes are lined up right, so that our new holes end up in the proper positions relative to the existing holes. Now there's a couple things we don't want to happen here. We don't want this V-jaw to move. So I'm going to set my little stop here so that the V-jaw won't move. And we're going to need to put some pins in here so that we can make sure that we're lined up straight along here. So I'm going to put some pins in here so we can put a piece of like a parallel on here, and then we can indicate off of this parallel to get these lined up straight. Alright, so we got 2 pins, which in this case are size W drills, which are a nice firm fit into these counter bores. These are metric counter bores. These are counter bores for a metric M7 bolt. So, excuse me, it's a size Z drill. You're probably wondering to yourself, Killer, why do you have 2 size Z drills? Well, anyway, this is a big piece of tool steel, ground tool steel. And then all I'm going to do right now, I'm going to get close just by taking my little hook rule and very gently rotating this around until I'm close. Just by eye. Alright, that's pretty close right there. So I'm going to get the indicator back in. We're going to put the indicator back in and we're going to sweep this face, and that'll line these 4 holes up just about as parallel as I could want to get them. Alright, got my Noga indicator holder back in here, got my indicator back in. I got about a turn of preload on there against that piece of tool steel. Make sure everything's snug. Now this is tricky because you just got to get a number, and then don't move you cannot move your spindle, right? Okay, I'm less than a tick off, so let's try it one more time. Okay, I'm still less than a tick off, so that line up with the ruler is pretty darn accurate. Don't underestimate a quality scale and, well, good reading glasses. So you young guys wouldn't know about that. Anyway, so we're lined up. We're square here. We're tight in the vise. Let's go ahead and break this down and get our drill and tap out, and let's we're going to use the bolt pattern we're going to use the bolt pattern function on the DRO to knock these 4 holes in. All right, so we're going to go over the bolt hole function for the Sino DRO, which is comes from Shars, and it is really, honestly, a fantastic piece of equipment. And for the money, I really don't think you can beat it. Anyway, I'm already zeroed up on my center here. So what we're going to do is we're going to come in there, we're going to hit the bolt hole function key. Then we're going to choose XY. Center position is our 0, 0. That's where I always start. Hit down arrow. Diameter is going to be, let's see. Diameter is going to be 2.8346. Enter. Make sure you hit enter after all your entries. Down arrow. Number of holes. We're going to have 4 holes. Enter. Down arrow. Starting angle 0 up top. That's where we're going to start. And ending angle is going to be 270, which is where we're going to go all the way around. And down arrow. Okay, first hole. So we're going to come over until our X reads 0. Alrighty. So run hole number 1, X reads 0, and then we're going to do a little spot here. Running backwards. Now, you see this jumped a little bit. Nah, no big deal, right? So hit next hole. Alrighty. All right, once we're zeroed, do another spot. And we just hit the down arrow, hole number 3. So anyway, we just keep following it around, and it keeps giving us coordinates. So in this case, I'm going to make 3 laps. I'm going to make 1 lap spotting. I'm going to make 1 lap drilling through with a number 7, and then I'm going to make 1 lap tapping. And I'm only going to change my tools 3 times. The DRO is plenty accurate to put you back on the hole every single time without having to swap tools at every hole. So, but I'm not going to make you sit here and talk you through all those moves. That would be just boring to get at. You get the idea how it works. You keep hitting that down arrow, it's just going to keep rotating on around. we've gone around, drilled them, spotted them, drilled them, and tapped them. So this part is ready to mount back on the machine, and we're ready to move forward with mounting the power feed adapter on and the power feed itself. So let's go ahead and take this out, clean up the anchor lube, and then get on about it. All right, we got our part drilled and tapped for this extra bolt hole pattern here, and we're going to get about remounting the shaft in the machine, and getting this all set up, and drilled and tapped these 1/4x20 using a OSG 1/4x20 2-flute tap. If you like that size, or if you like that style tap or OSG brand, killer sale at Hurco right now. 1/4x20 OSG spiral points for $3.95, something like that. I use that size all the time, so I bought quite a few. That's a great price. Regularly, those things are around 10 bucks. Anyway, let me get the camera aimed around, and we'll go about assembling everything else we need to get this thing mounted. Sorry for the upside down shot. So what we're going to do right now is we're just going to assemble this as a little mock-up. I have not put the bearings in yet because you have to press those in, and that's kind of a pain to undo, so I'm just going to wait till everything is complete. So right now I'm putting in the bearing retainer. Now we're going to mount up the adapter. Like I said earlier, I have no idea if this if this 3D printed parts can be up to the task, but we're going to give it a shot. Alrighty, there you are mounted up. Off video a couple days ago, I wired up this box over here to power this thing, and it'll also work for my DRO. So anyway, I don't have it bolted up yet, but getting there. We've got to mock up the hand wheel now. That's right. Bozo has visited the shop. Bozo didn't visit the shop just once. Bozo visited the shop 2 times. But primarily one big bozo. Not a machining mistake per se, but a design mistake in this adaptation that's going to have to be overcome. So let me move the camera in closer, and then we will detail the issue here and make it clear for everybody. Alrighty, and move the miscellaneous parts out of the way. Here's the original shaft, right? That we replaced. This is the section, just to refresh you, this is the section that goes into the female adapter that attaches it to the lead screw. This is the section for the bearings. And there's this section here. This is the issue. And then here's the shaft with the key and end threaded for the retaining nut. you notice on my replacement, just longer, because it needed to be longer because of the space that the power feeds have set up. Here is the section again that goes into the female adapter. Here's the section that the bearings run on. There's a piece missing here. I don't know what gave me the idea that I didn't need that little section of shaft there, but this is the section of shaft right where the power feed, well, not really right about here, but the bearings go here. Then I've got the bearing retainer plate. Then I've got the adapter. So about out here is where the power feed rides. Well, the power feed has a Torrington style bearing in it. And like a lot of those, it has a hardened insert. Here's the insert right here. And, well, there you go. This ID needs to be adapted to this OD, right? It doesn't fit. So the shaft, that shaft is going to have to be adapted. So what I've got here is a bronze bushing blank that is going to have to be machined on both the ID and the OD to fit this application. So there you go, that's the bozo. This dimension right here should have been left, and it would have had to have been longer. So should have left this on there, and I didn't. And you know what? I didn't make a drawing of this. So there's your mistake right there. Like I've said many times, better drawings make better parts, at least for me. It's because I have the attention span of a squirrel. So anyway, let's get the bushings here. Let's get this bronze bushing mounted up in the lathe, and let's turn this to size, and let's take care of bozo attack number 1. All right, we're gonna modify this bushing here. A bushing inside a bushing. I realize it's kind of a cluster. The ID needs to be about this is exactly 5/8, so we need a slip fit over 5/8. And what we got here to start with is 542, 543. So let's get this in the lathe and let's punch this out. All right, got our little bushing here, chucked up lightly. Don't want to compress it. Got a small boring bar mounted in the tool post. We're at about 540. We got to come out to a little over 625, so we have almost a full 100 thou to take out of there. Got to get fairly close, so I was just judging where I needed to stop with my power feed. So we got plenty more to come out of here, so let's make a couple passes. got some bronze flying all over the place. Let's see what we got. We're making one more final little pass here. And slow the feed down to 3,000 per rev. And we're going to get us a really nice finish. In there. That's what we're looking for there. Really nice snug fit. So now what we're going to have to do is cut the OD. Alright, I'm going to show you how to make a little quick and dirty, and I do mean quick, expanding mandrel for this case. We only have to take about 3 or 4 thou off of the OD of that bushing. So you're really just talking about, especially with bronze, just buffing it a little bit. So what we're going to do here is I got this piece of plastic. Pretty sure it's polyethylene. It's got a little nose on it right here. And what I'm going to do is I'm going to turn that nose back a little bit farther to fit this bushing. Alright, got a little piece of plastic here cut. The bushing fits on there rather snugly. Now what we're going to do we're going to pop a little hole in the beginning. Pop a little hole in here, a little center. Nothing major. Now what we're going to do is little unorthodox work holding technique. We're going to take a screw and we're going to screw straight in here. There you go. Now that baby is on there. So here's the bushing that we need to fit on the ID. Almost. Not quite. Good enough. That'll give me a really nice little light press fit, which will keep this bushing in there. There you go. That's Kilroy's unorthodox work holding technique of the day right there. All right, there you go. Little screw down in here. Just expanded that plastic and gave us a nice grip fit. This little piece of plastic here is, you know, sacrificial. You can throw it in the trash. And the bushing just starts, wiggles on into the hardened bushing that has to go around it. So I'm just going to press that in there. And this part of the adaptation is finished. Now this technique, the little screw expanding mandrel technique, you can take light cuts and obviously do you know, finishing techniques like filing or emery paper, but you can't you know, take heavy cuts. There we go. There's our sacrificial piece of plastic. All right, we're back over at the mill. We've got our shaft here. And what we want to do now is drill the cross hole. There you can see the one in the original part. We want to drill the cross hole to hold this end of the stub, the female stub, off the end of the lead screw. It takes a 6mm split pin. And the dimension that's important here is the dimension from here, from this surface to the hole center down here. This dimension is not important. This dimension is important. So what I did is I took the original part and put it in. I've got it in the bearing area, this area here, right here, in a 5C collet, in a collet indexer that's just sitting in my Bridgeport vise in my mill. I use the little handy little centering fixture. Some people don't like, but I certainly do. They worked out real well. And use that to center it up and lock my Y down. And now I want to get this dimension right here. I want to get centered on this hole, the factory hole. So I'm just going to loosen this up a little bit. Rotate this on around, get it straight up and down. I already got a drill bit in here. This is a size C drill. It's my closest drill to that hole for the 6mm. And now I'm just going to kind of line it up. There we go. I can live with that. Take the drill out. Put our little, we got a little spotting drill here. 1/4-inch spotter. Let's take it out. Put the replacement piece back in. Snug that up in the collet. There we go. Wrong way and back gear, all sorts of stuff. Alright, we got a spot. Spotting drills are the bomb because they have the same point angle as your drill, right? So when your drill hits the spot mark, it isn't chattering a couple of cut lips. Let's go and drill on through. Alright, there we go. So our through hole for our split pin is in place. There we go. And let's keep moving. Alright, so we've got our bushing here made. Rides on here. We've got our split pin hole made. We're about ready to fit this thing up. We just need to discuss the last item of, I guess, adaptation contention. I guess you might call this a visit from Bozo, but not really. It's just a peculiarity of the machine. This is the dial. So the way this thing all goes together, the shaft comes through like so, then the drive gear takes the place of the old holder. This was the holder for the dial. It takes the place of that. So here's our drive gear. You have to put some bushings and shims. There's a little pack of shims and stuff. I have to spend some time shimming that. You get some shims, you get that in there. Then your dial is supposed to go on here. So I wonder if you notice anything peculiar about that. The dial for this machine is significantly larger, probably close to a ½ inch in diameter larger than stock Bridgeport dial. So it no fit. It impacts the casting of the housing down here before it ever gets up flush. And then there's also a gap back here. So grit and swarf and nastiness could just fly right in here and pollute the housing where the gear goes here. Well, I don't really care about these because the machine has a DRO on it, and it's been so long since I've used a dial that on that machine that I honestly just don't even remember. So I don't care about that. So, but I still need a way to fill this gap and seal around this surface so that grit and swarf and other nastiness doesn't get down in here with the gear. And then once that's in place, then your handle, the actual crank handle, goes on, and you notice that I've got plenty of extra length here. Once this is all fit up, there won't be as much extra length. I've got to turn and thread this end for the nut to hold all this in. This nut that goes in here is what holds everything in, and including the drive gear, everything else, it all gets held in with that nut. So what I've got to do now is go ahead and get this all mounted up. Go ahead and install the new shaft with the split pin, at least started in, and go ahead and mock this all up so that we can figure out, how long I need to cut this off so that I can get this turned down for the nut to capture all this in. Once that's done, then it's really just a matter of shimming the unit and powering it up and running it. And figuring out what we're going to do with this gap. I'm probably going to have to make some sort of adapter to rest over this diameter and fill in here around this gap just to keep any junk and stuff out. Because, like I said, the other downside to this dial, I thought, well, I'll just buy a Bridgeport dial that matches this machine. So one problem. This is 250. The travel on this lead screw is 1/4 of an inch per turn, 0.250. I cannot find a Bridgeport lead screw dial with anything other than 1/100th of an inch or 200th of an inch. So if anybody knows where I can get a Bridgeport style, a Bridgeport size dial with 250 thou travel on it, let me know, and I'll throw it on there so that I have a dial, even though probably won't be used. It would be nice to have. So anyway, that's where we are. There'll be one more video in this series where we will finish this up. We'll go through the shimming process. There's some detailed instructions. We'll go through the final assembly. We'll plug this baby in and make it go back and forth. We'll mount the automatic stop pickup here and test that out. So that'll be in power feed number 5. And until then, be safe in the shop.